Hello, and welcome to an episode of Yes Repair. I'm your host, Mr. Fix-It. In this video, I'm going to show you how to identify your transistor and help you understand these data sheets that you'll find and some that comes with the transistor. Because a lot of this information will be helpful if you ever have to replace your transistor. So let's get started. Here I'm showing you common transistor package groups. And what this is each transistor has a certain package group name. And this identifies as to how it's made or the shape that it's made into. You have them from the left to the right. The TO92s, which are the smaller ones. These handle very little current. As you work up, you go to your medium power, which is around the T220s and the TO3Ps. And then you get your larger power, which is the TO3s. Now most transistors will have 3 pins, but transistors like the TO3s, they only have 2 pins because the casing, as you can probably see the mounting holes on the TO3 there, is used as a conductor. Now to find out what these transistors are, we'll need to look up the numbers. Now, these transistors are not the same. So how are you going to look them up? Just use the internet. If you have a reference guidebook, you can use a cross-reference to look these numbers up. Or you can go online and look numbers up to find out what the transistor is. Because in order to identify it, you have to look up the numbers. Next, here are the parts of a typical transistor. Here you have the tab or the case. The case refers to transistors like the TO3, and the tabs refer them to like the T220s and stuff. But this is what allows the heat to be dissipated for these medium to high power transistors. You'll also see a manufacturer. This is who made it. You'll see a date code, which refers to the date code which it was manufactured. You'll also find an identification or part number. This is most important. This is the number that we're going to go by to identify your transistor. And of course you have your pins. Well, when you look up the part numbers or the identification numbers on the internet, you'll want to look for something for PDF format or data sheets. This data sheet will give you all the information pertaining to that single transistor. As you see here, this one here pops up. This is the information for my tip 120 transistor. As you can see here, I have it highlighted to identify the markings that I used to look it up with. Now you'll also notice up there at the top that it says tip 121 and tip 122. Well, those are related to the 120, which I will show a little later in this video. Next, you have the identification of what the transistor is. Here it says it's an NPN, meaning it's a bipolar transistor. The P means that the base must be a positive charge. If it was a PNP, it would mean that the base would have to have a negative charge to turn on. To the right, you'll see my symbols. These are the common symbols used to identify an NPN or a PNP. Now for NPNs, the current will flow through the collector and out of the emitter as indicated by the arrow. And the base requires to be positive in order to turn an NPN transistor on. For NPNs, as you can see, it's the opposite. Current will flow through the emitter and out of the collector, where the base has to be negative in order to turn the transistor on. Now, as you can see, they look almost identical, except their polarities are the opposite of one another. Remember, NPNs require the base to be positive, and the PNPs require the base to be negative. Now we have all the circuit. Now this shows it's a Darlington transistor. Now it's still an NPN transistor, but as you can see, instead of having one transistor, this one contains two transistors inside, meaning that one transistor turns on another transistor. Now the circuit that I have circled shows a typical circuit that is the same thing as this Darlington transistor. Now if you didn't have this transistor, the circuit can be used as a substitute. Now the next section you'll find is a description, a brief description defining as to what the transistor is used for. It'll show mostly its primary functions, and it will sometimes show alternatives as to what the transistor can be used for. Here, the transistor is used for medium power linear switching applications, meaning it can handle a medium amount of power, or amperes. And it's also designed for switching applications, such as switching regulators, switching power supplies, anything that requires pulsing. The transistor is designed to be able to be turned on and turned off rapidly. You'll also notice it says complementaries. Now, this refers to brothers or cousins, whatever you want to call it, to the transistor. In this case, the tip 120 complementary transistor will be the tip 125. Now, this means that since 120 is an NPN, the 125 is a PNP. Now, they all have the same ratings and everything. The only difference is they're opposite of one another concerning to polarity. So you want to watch out what you're using and be sure you're using the correct polarity if you're replacing these transistors. Next, we have the orientation. Now, this is also important because it shows the relativity of the transistor and to help you identify the first pin, or number 1. In this case, it shows that the transistor is laying on its backside with the front facing up or towards you. Now, as you can see, it shows where the pin 1 is. Now, below it, it shows that pin 1 is the base, collector is number 2, which is the center pin, and emitter is number 3, which is the pin on the right. Now, it also shows you the package that or the package group, which is TO220. So keep in mind that the orientation will show you and help you identify which pin is which, and where pin number 1 starts, and to help you identify the other pins on the transistor. Now we have voltage limits. Now, with voltage limits, this identifies the maximum voltage that the transistor can deal with. Anything that's higher than the stated voltage limit will damage the transistor. Now, here you'll see 3 groups, or 2 groups. You'll see the 121 and the 122. Now, as you can see, the only thing that differs between the 3 is their voltage rating. The 120 can handle up to 60 volts. The 121 can handle up to 80 volts. and the 122 can handle up to 100 volts. Now remember, the complementary transistors are the same thing, except the polarities are backwards, or I should say opposite. Now if you look up a PNP transistor, all these settings on here, or all these ratings, will be negatives because it's a negative transistor that requires negative power to turn them on. Next, we have the reverse bias limit. Now, this is the maximum reverse voltage before breakdown occurs. Between the emitter and the base, the emitter can only be 5 volts, and this refers to the collector being open, as the symbol says. VEBO stands for the voltage of the emitter to the base with the collector open. That's what the O is for. And if the emitter is 5 volts, you cannot go any higher. Otherwise, the transistor is damaged. Now, I can show you later in different videos when I show you how to test these things, and show you in videos on how to use a lot of these transistors, to what you can do to protect that transistor. Next, we have the maximum current load that this transistor can handle. Now, you can handle anywhere between 0 to 5 amps with this particular transistor. All transistors are the same, but this is the information. It shows how much current your transistor can handle. Now, in some cases, you will also find a maximum load current for a pulsed transistor. This means if the transistor is pulsed, meaning rapidly turned on and off, then it can go up to 8 amps. Now, it also refers to an initial surge current. So, when you first turn on the transistor, there could be an inrush current, such as starting a motor, which motors do require more current to start than they do to run. Well, in this case, you're allowed to go up to 8 amps, but only briefly. Next, you have the maximum base current. Now, the maximum base current refers to the base, and it only requires no more than 120 milliamps. Now, each transistor shows you will either be identified as a base or a gate, which I'll show you at the end of the video, the different ones that you'll come across. And this one here shows that it only requires 120 milliamps. That's very tiny if you compare this to 5 amps. 5 amps is the same thing as 5,000 milliamps. So you can see the huge difference between a 120 milliamps and 5,000. This is the advantage of Darlington transistors. They reduce the amount of current required to turn them on to where you can control a much higher current with very little base current. Next, you have the wattage, collector dissipation, or power dissipation. Now, you'll see the symbol in parentheses where it says like a TA, like it does here. A lot of transistors have these, and it'll say TA equals 25 degrees Celsius. Well, that's right around, I think, room temperature. I'm not familiar with Celsius, but TA refers to ambient temperature, just the air. Well, as you can see here, I have it listing. The data sheet on here says 2 watts for TA if the ambient temperature equals 25 degrees Celsius. Well, that's referring with no heat sink. This is the transistor convecting heat directly to the air. It means it can only do 2 watts maximum. The second part identifies if it's connected to a heat sink. This is a TC equals 25 degrees centigrade, which is again room temperature. This identifies that if the transistor is connected to a heat sink or a proper heat sink, then this transistor can dissipate up to 65 watts. The heat sink's purpose is to draw the heat away from the transistor. The bigger the heat sink, the more the heat it can draw from the transistor. But the transistor can only safely dissipate 65 watts. Now, later in other videos, I will show you different versions of heat sinks and how to calculate the kind of heat sink you'll need for different transistors. Next, we have the maximum transistor temperature rating. Now, this is very important. This means this is a maximum temperature that this transistor or your transistor can operate. For instance, this says 150 degrees centigrade, which if you convert it to Fahrenheit, it would be 302 degrees. That's pretty hot. Well, if you have your heat sink attached, remember if you haven't seen it, go ahead and watch it. I did the digital multimeter tutorial part 2, which uses the temperature probe. And the temperature probe comes in handy to monitor your transistor to make sure it doesn't overheat, because this shows the maximum temperature of 150 degrees centigrade. As long as your transistor stays below that, then it will operate fine. So keep that in mind. Finally, on this part, you see the temperature range that the transistor can be stored. Now, this really isn't all that important, because it just shows that, if you're not using the transistor, it can be stored from negative 65 degrees centigrade to 150 degrees centigrade. So it's got a very wide range. Next, we have electrical characteristics. Now, you'll find a lot of these on transistors in this section. It pretty much tells you how the transistor responds in a test condition, to give you some kind of an idea of what to expect from the transistor. You have a collector, emitter, sustaining voltage. You have the cutoff current. You have the cutoff current on different conditions, such as the current from the collector to the emitter with the base open. This tells you that at a half milliamps, that using at 30 volts, it's going to take 1/2 of a milliamp before the current cuts off. That's how far it's got to drop down. Now, with the other one, it's collector, base, with the emitter open. Now, with the emitter open and you're running 60 volts between the collector and the base, well, when the current draw opens on the emitter, or the circuit opens, then it's going to drop when it gets down to 0.2 milliamps. But, these are test conditions. You'll see a lot of them on here about test conditions. DC current gain. Now, a lot of this refers to bipolar transistors because, like I said, they're amplifiers. For what little current they require on the base can control a whole lot bigger current on the other side. They are used for amplification. For an example, if you send 1 amp through a transistor, it may control 10 amps between the collector and the emitter. It's called amplification. It don't mean that the transistor actually will, but they do vary between transistor to transistor. But the DC current gain here shows you uh, how many times the current will uh, increase based upon the current that's going through the base. And this is how much current you can control. Now, it will vary according to the voltage and the current being applied to the transistor. Saturated voltage. Now, this refers to how much voltage it takes before the transistor is saturated, meaning that once the transistor hits, in this case, the collector is running at 3 amps and the base is operating at 12 milliamps, it takes 2 volts before the transistor becomes saturated. Now, saturated, to help reduce this and to help increase the transistor to switch quickly from on to off and to quickly adjust the current on the rapid pace, you want to use a resistor between the base and the ground for NPN transistors, or between the base and the collector or the positive on PNPs transistors. This will help pull the voltage out of the transistor once the base is turned off and help to increase the switching speed of the transistor. Now, as you can see here, the higher the amperage, the higher the voltage it takes to saturate. The base emitter on voltage refers to the collector and the emitter. Now, like say you got 3 volts, the current through the collector is 3 amps, then the voltage between the base and the emitter is only 2.5 volts. The output capacitance, you really don't need to worry about that unless you're using frequency, because when it's on or off, then the capacitance really don't matter. But when you're running at high frequencies like 100,000 kilohertz or 0.1 megahertz, then capacitance may affect the electronics. And this will show you how the transistor reacts during higher frequencies. Now, you'll also find different charts on these data sheets. Like the one on the left here, you have typical characteristics. Now, this shows how the transistor responds in different conditions. This gives you an idea of what to expect through the transistor. Now, when you're testing these transistors, this will also give you an idea if the transistor is functioning properly. And if it's not, you can tell by this chart. It will also show you your DC current gain. It shows you your safe operating ranges, and it shows you how your transistor will derate on high temperatures. And when you're testing transistors, these charts will give you an idea of how this transistor should perform. On the right really isn't all that important. It's the mechanical dimensions. This shows you all the measurements of the transistor. And unless you're building electronics, you really don't have to worry about the physical dimensions of the transistor. But it just gives you an outlining of what the measurements are. All the measurements are millimeters. But basically that's all that's for. And this is pretty much what you'll find on data sheets. All the information pertaining to that transistor. Now, in some circuits, you will also find examples of how the transistor was tested. You can find examples of how the transistor can be used, like MOSFETs and SCRs and a bunch of different transistors. Some of them will show you examples of how you can use a transistor or how it is used. Finally, we have the symbols that I'm going to show you. These are the symbols for bipolar transistor symbols. As you can see on the left, you got the NPN and the PNP on the right. This is what their basic symbols are. In the bottom, I show you what Darlington transistor symbols look like. Now, they have two different kinds for the NPN Darlington transistors and for PNP Darlington transistors. They're basically the same. It's just the only difference is the polarities are different. They're opposite of one another. But here you have two different kinds of what Darlingtons would look like on a schematic. Now, when you see these on transistors, then you'll at least have an idea, because not all of them will show the symbols. Well, this one here should help you identify the transistor. If it just says NPN but no diagram, how do you know what pin's which or what the orientation is? Well, this will help you. Other transistors that you'll come across, for an example, here you got field effect transistors, such as a metal-oxide semiconductor field effect transistor. You'll have JFETs, which are junction field effect transistors. On the right, you have thyristors. You have the triode for alternating current, or TRIAC for short. And you also have the silicon controlled rectifier. Now, these I will also show you in videos on how these are used and how you can test these. It shows you how you got N channels, P channels. In other videos, as I move along, to show you how to use different transistors and how to test transistors, this will come in handy. But these are the symbols that you'll come across. And later on, I'll help you test these types of transistors. For the thyristors, the triacs, you'll find these in a lot in lighting and other small, anything that requires controlling alternating current. Silicon controlled rectifiers are found in power supplies and some things that requires a trigger or something. It's basically a diode is what it is. It just has a gate that turns it on and off. But it's a lot of times used in DC. MOSFETs, the N-channel versions, you find a lot in switching power supplies, car amplifiers. JFETs can be used in audio amplifiers. But this is basic what you may run into. And as I move along and introduce new transistors, I will also add these onto the list. Well, this is the end of this video. I hope this video was helpful. This video was presented by ES Repair with your host, Mr. Fixit. You can find us on www.youtube.com/user/ESRepair. You can find me at www.for-mrfixit.com. If you like this video, please subscribe to our channel to receive the latest updates and uploads of our channel. And please remember to vote on our videos to let us know the videos that you liked or disliked. And this way you can let everybody else know too. Well, thank you for watching.